Hello everyone, this is Mrs. Logus and I will be taking you through Unit 8B, which is all about different types of equations. In fact, a lot of these you have seen either earlier this year, briefly, or when you took AAA, AA, and other math classes before then. So in the past, this unit has been just all mixed up, all the equations just all on one page. But what we decided to do this year was make a lot of individual videos. So if you're having trouble with any specific topic, you can go back and rewatch that. But in class, you're going to be doing a lot of cumulative review. The way that I wrote the assignments is that every day it's not just a particular type of equation, it's going back to the stuff you've already learned. Speaking of things you've already learned, we're going to be spending a little bit of time on polynomial equations, then going to absolute value equations, rational or fractional equations, radicals, equations with rational exponents, solving equations with U substitution, and rational inequalities. Some of these might pop out to you as I'm a little bit more familiar. Some you might need to watch the videos more than once, and that's why we're splitting it up for you. So let's get started on polynomial equations, and we're going to be focusing specifically on cubes and perfect squares. And remember, one of the main goals of this unit is for you to decipher between the types of equations and find the best way to solve each equation eventually. So thanks for sticking with me throughout this unit. So if you can go to your note packets, here are the main things we want to focus on in this polynomial equations video. You might be saying to yourself, Mrs. Logus, we have already spent so much time on polynomials with synthetic division last unit and even just quadratics before. You're right. This semester is very cumulative, so we always want to start with what we know. So I want to focus on these three formulas, the difference of squares, difference of cubes, and sum of cubes. If you would like, I would suggest pausing the video and copying down SOAP, same, opposite, always positive. And something you've seen earlier is instead of writing these difference of cubes in terms of x's and y's, you've actually seen it in an earlier video by Ms. Schwartz written with a's and b's. So please pause the video now and copy this down so when I go through examples it makes more sense. Okay, let's take a look at number 1. So if I'm taking a look at this first example, what I want you to notice is that you can use the same methods we've been using the whole time. Split the middle if you need it, grouping if you need it, and greatest common factor if it's appropriate. For number 1, if anyone was looking with me and noticed that you can take out an x squared, I completely agree. So let's take out the GCF of x squared, and you're left with 9x squared minus 24x plus 16 equals 0. And the goal of all of these is to solve, not just factor. So now we take a look at what's left over. And the reason why this particular example is in this video is because I noticed that for the difference of squares formula, that the first and last term are both perfect squares. So according to the difference of squares formula, if we find what the perfect square is, it becomes plus and minus. So if I write the x squared again in front, this next part should factor to be, well, the square root of 9x squared is 3x, and that will repeat over here. The square root of 16 is 4, so I'd write that on the back end of the parenthesis. And then I'd decide, how can I get this middle term of negative 24? Well, I notice if you think about FOIL, this term is 12 and this term is 12, so to get it to be negative 24, both have to be negative. You could always go back and FOIL this out to make sure you get what's in the red. So now if I solve this equation, we have x squared equals 0, and this is the same root twice, so 3x minus 4 equals 0, so x would be 4/3, and x would be 0. Now some of you might be wondering, wait a minute, this is a x to the 4th polynomial, so how come I don't see 4 roots? Well, this one has a multiplicity of 2 from last unit, so this root repeats twice, and this is x squared equals 0, so this root repeats twice as well, so both of these are double roots, so we do have 4 roots indeed. This next example is a good one because we have x to the 6th, which is a little bit more unfamiliar, and a lot of students ask themselves, how do I start something with x to the 6th? So first, I just want to throw your way. If you think of this as a similar idea as x squared minus 64 equals 0. If you solve this problem instead of this one, the x squared and the 64 are perfect squares. So what we would do is say x plus 8, x minus 8. So I'm going to erase this, but in the same way, if I thought of this using perfect squares first, the square root in the way of x to the sixth is x to the third times x to the third, because you add those exponents. And then the square root of 64 is still 8 and 8, and we can treat it as positive and negative because we want the middle terms to cross out and become 0. So now I notice that this problem becomes x to the third, which means we can use the difference of the difference of cubes or the sum of cubes. So what I notice is that we have a sum of cubes here and a difference of cubes here. So we'd have to use both of these equations, which is a little bit of a pain, but I'm glad at least we have a formula for it. So this one I will do in red. This is the sum of cubes formula, which is right here. And so notice the idea of SOAP is that you have the same sign, opposite sign, and then this one's always positive. So what we need to think about is what A and B are first. So in this parenthesis, think cube roots. The cube root of 1x to the third is 1x. The cube root of 8, or what number times itself 3 times gives you 8, is 2. So this is your A term and 2 is your B term. And so if I plug into this idea here, we would have x plus 2, and then this part would be x squared, the A term, minus the A and B term multiplied, which would be 2x, and then always positive, and the B term squared, which is 2 squared, or 4. So this splits off into these two. If I switch colors, this one, the difference of cubes, is this formula, and ends up being almost the opposite of what we just did. So the A term is still 1x, and the B term is still 2. But now we follow this formula, and we say x minus 2, x squared plus 2x plus 4. So notice with the blue, again, it's same sign as this, opposite sign as this, always positive. And now all of this still equals 0. So here's what I want you to do. I want you to pause the video and see if you can find all of the roots or imaginary roots. These, if you set it equal to 0, are easier. These, you probably have to use the quadratic formula for. So please pause now and try to find all of your roots. I will come back with the answers. So when I did my solving, I got the first one to be x equals negative 2 as a root, and this is x equals positive 2. Both of these quadratic formulas ended up being a very similar idea. Both of them, when I went through the math, I ended up getting imaginary answers. I hope you did as well. One of them, I got x equals 1 plus or minus I root 3, and x equals negative 1 plus or minus I root 3. If you'd like to pause the video and copy any of this down, you're more than welcome. But again, what I want to point out to you is that we had a sixth root at the beginning. It looks like we had 2 real answers, 2 imaginaries here and 2 imaginaries here, which did add up to 6, but it is okay not to have all 6 as real roots. So please pause the video if you'd like, and I'm going to go on to the next example. Okay, last 2. This example, I notice again, we do have an x cubed, so we could probably use the difference of the difference of cubes or the sum of cubes. So what I want to point out to you is that if you think cube roots, the A term would be the cube root of 27 is 3, and the cube root of x cubed is x. The B term, the cube root of 64, or the number times itself 3 times that gives you 64, is 4. So what I'd like you to do is use the formulas that we used for this last example here, the SOAP formulas, and I want you to get as far in this problem as you can, and I will come back with the work. So please pause the video now. So to take you on my work so far, I ended up using this formula because we have the same sign, opposite sign, always positive. So make sure when you plugged it into the formula, I tried to show all my work here in this step. You would have a minus b, a squared, which ended up being 9x squared, plus a times b, which was 12x, plus b squared, which is 16. So this is what should this is what it would factor to be. And then if you want to solve, one of your answers would be positive 4/3. And this is where, again, I'd like you to pause the video and use the quadratic formula to find those roots. So please check your work and please pause again to use your quadratic formula. All right, guys, so you can check your work. I ended up getting imaginary answers again. Underneath the square root, I got negative 432, which I split into 144 times 3. Don't forget it's imaginary because of the negative under there, so make sure you have 12I root 3. Then I reduced that because of this triangle of like terms. You can take a 6 out of all of them. So I got x equals negative 2 plus or minus 2I root 3 all over 3. Last but definitely not least is example 4. The reason I put this one in the video is because, again, when you have a higher order polynomial, it's easy not to know where to start. So I just wanted to do at least one with you. When I see x to the 4th, the first thing I'm tempted to do to try to see if it works is think perfect squares. So I noticed that x to the 4th I could write as x squared times x squared. Now 56, though, is not a perfect square. So I go back to my original thought about factoring and think about, can I find two numbers that multiply to be 56 and can combine to be negative 15? And I think to myself, negative 7 and negative 8. So let me plug 7 and 8 minus minus into my formula or into my factoring. And I want to double check. So if I FOIL backwards, I get x to the 4th minus 8x squared minus 7x plus 56. And if I check that, I do get my original function. So I'm good to go. So this problem is actually the fastest one of any of these problems today, because now you could say x squared minus 7 equals 0, x squared minus 8 equals 0, x squared equals 7, x squared equals 8. Take the square root of both. So here, I'd actually not get imaginary answers, but I would get plus or minus root 7 here. And here I would get originally plus or minus root 8, but root 8 could be split into 4 times 2. So I would say a better answer would be plus or minus 2 root 2. Yes, an answer that does not have imaginaries. That's nice. But we do have radicals, which again is okay. So again, the point of this particular polynomials video is to focus on the difference of squares, difference of cubes, and sum of cubes. This video again will be here if you want to review just polynomials at a later point. A lot of smaller videos are to come. I'm going to try to keep them about 10 minutes. I know this one was a little longer because of the explanation of what we are doing generally in the unit. So thank you for joining me, and I will see you next time for absolute value equations.